Okay. So anyway, okay, so which of the following statements is true? The limit as x approaches 5 exists. Yes, it does. I'm looking at it, and it does. So you can just stop there, right? Are there any questions about why all the rest of these are false? No questions? All right, good. Polls are okay. Jumps are bad. Yes. The limit as x approaches 1 equals f of 1?
No, the other one.
What? Oh, E. I thought you said D. This one? So I'm assuming I had it cut off. F of 5 minus f of 1 over 5 minus 1.
Yeah.
Okay. So this is saying, does the slope of the secant, so does f of 5 minus f of 1 over 5 minus 1, so that would be the slope of this line, does this equal f prime, why does it say f prime of c?
Yeah, that's what I was confused about.
Yeah, what is c? I wonder if that's a typo. It doesn't equal a derivative anywhere though, right? Yeah. So it's not going to be true.
But doesn't it have to equal like a slope in that area because of the MDT?
It's not different. Oh, it is continuous. No, it's not continuous on the closed interval. It has to be continuous on the closed and differentiable on the open for MDT to apply.
What does it mean by closed?
It means it has to be continuous, including at the endpoint. Yeah. So since it's not continuous on the closed interval, MVT does not apply. Yeah. Wow, a lot of good questions. You guys are like have your thinking caps on today. All right. Moving on to number 2. So limit as h approaches 0 of f of 3 plus h minus f of 3 over h. That's the same thing as saying as I could call that what? What is this whole, not the equal 0 part, but what is this part? It is in specifically it's f prime of 3. Right? You guys remember your 3 limit definitions? Might want to look them up, right? This is, since there's no x's, there's numbers, so this is the definition of a derivative at a specific point. There's 2 of them. The limit is h approaches 0 of f of a plus h minus f of a over h, or the limit is x approaches a of f of x minus f of a over x minus a. So if you don't remember those, you might want to look them up. It's good to know because 99% of the time those problems involve recognition, not recall. Like you don't have to do it from scratch, but you have to be able to recognize it when you see it. All right. So anyway, so what is the statement saying? It's saying, hey, f prime of 3 is 0. So does f have a derivative at 3?
Yes.
Yes, it's 0. Is f continuous at 3?
Yeah.
Yes, guaranteed. Why? Because you can't be differentiable if you're not continuous. Right? That's the first required. Oh, look at Keegan's face. There are 3 rules or 3 conditions for differentiability, right? Number 1 is the function has to be continuous. Number 2, the function can't have a sharp turn. And number 3, the function cannot have a vertical tangent at that point. So continuous, no sharp turns, no vertical tangents. 3 conditions for differentiability. So if the derivative exists, which it does, it's 0, then the function has to be continuous there. All right. Does f have a critical value at x equals 3? Yes, absolutely. Definition of a critical value is f prime is either what or what? 0 or undefined. Yep. All right. And they have to be in the domain of the function, but this has to be in the domain of the function because it's differentiable there. All right. Okay. So number 3. A pebble thrown into a pond creates circular ripples such that the rate of change of the circumference is 12 pi centimeters per second. How fast is the area of the ripple changing? So I guess we're just talking about one ripple when the radius is 3 centimeters. Okay, so let's write what we know. Rate of change of the circumference. I'm going to call circumference C. So dc dt equals 12 pi. That is given. How fast is the area of our ripple changing? So we're looking for dA dt when the radius r is 3. Okay. So there's two ways to approach this. I'm going to go ahead and just take a moment and write formulas for both circumference and area, and then we'll discuss how to approach. What's the formula know for circumference of a circle? 2 pi r. What's the formula to know for area of a circle? Pi r squared. All right, so we're trying to find dA dt. There are two ways you can do this. One way is you could solve this for r equals c over 2 pi, and replace the r in this equation with a c over 2 pi. Totally fine. Or you could go ahead and just differentiate this just like it is, differentiate this just like it is, and then this guy you plug in and it'll give you dr dt, and then you just plug that into here. It sounds complicated, but it's actually really easy. Oh, whoa, mind blown. Okay. I'm assuming most of you substituted first. So I'm going to show you the other way. Okay? So the other way, if we just differentiate dc dt equals 2 pi dr dt, right? So dc dt is 12 pi. So dr dt equals 6. Then you go over to your area formula and you say, hey, dA dt equals 2 pi r dr dt, and you just plug in. So pi r is 3, dr dt is 6, and the answer is 36 pi. Right? I don't know if that's easier or harder than substituting first. It's really probably kind of a potato, personal preference thing. Yes, Anisha?
Are there going to be like really complicated, like related rates?
Do you consider this one complicated?
No.
Okay, then probably not.
So is this like the most it's going to get?
This is about average.
And then for like optimization?
Optimization only appears on the AP exam in the context of finding absolute maxes and mins in problems. Yes, there will absolutely be finding absolute maxes and mins. Like that's a given. In the terms of like the volume of a box is there a farmer in a field or whatever, that's really rare. Like I haven't seen that on the AP exam almost ever. It's so it shows up all the time in every single calculus book, so we do it, but it's like rarely on the AP exam.
So will it be on the test?
I'm not answering questions. Will it be on the test? I'm just giving you background feedback. Yes.
So I don't remember what that poster is for, but will that be on the AP exam?
How to write an absolute value function in piecewise?
Yeah, what was that?
Yes, that will be on the AP exam.
What was that for?
To when you have to find a derivative or an integral of an absolute value function,
Oh.
you have to write it as a piecewise. Yeah. So yeah, the question was, will that be on the AP exam? So you didn't ask about your final. You asked about the AP exam, and I'm saying yes, that is certainly fair game to be on the AP exam.
Very similar to our AP exam.
The final is 2/3 of an AP exam. So who knows what's going to be on there and what's not. It's just this madcap, crazy final. Who knows? Okay. Will there be a derivative? I will answer that question. Yes.
What?
There will be a derivative on your final exam.
I can't.
And an integral.
Whoa.
Huh? Yep. Yep.
Will there be?
Okay. And numbers. And variables. Yes. All these things will be on your final. Okay, find the area in the first quadrant bounded by 2 cosine x, 3 tan x, and the y-axis. So, all right, 2 cosine x, something like that. We're only in the first quadrant. 3 tan x would be something like that. So you're doing in the y-axis. So that kind of a thing. All right, so you need to find whatever that point is there. So I don't know what this point is. It's wherever 2 cosine x equals 3 tangent x. So you could just graph them both and find the point of intersection. So does anyone have that by any chance? 0.523 something? Okay. Alright. Okay, so then your area is the integral from 0 to whatever you got there, or 0.523-ish with more decimals in your calculator, right? Of top, which is 2 cosine x, minus bottom, which is 3 tan x, dx. Whatever that is. Yes, Steve.
This isn't necessarily related to this problem, but I was like trying to figure out how to find the point of intersection without using a calculator. How do you do that? Because it doesn't even work.
Did it not work well?
No, it worked out fine. I just used my calculator, but I was just.
No, I mean, like, to do this by hand, if you set 2 cosine x equal to 3 tan x, so 2 cosine equals 3 times sine over cosine. Well, let's see here. So you have cosine squared equals 3 halves sine x minus sine squared sine x. So sine squared is 3. Let's see, plus 3 halves sine x. Let's see, minus 1 equals 0. And then you could double everything if you wanted to. I don't know. Does this factor? Let's see. Let's double first. So you have 2 sine squared plus 3 sine minus 2. 4 and 3. So you have, so let's see. 4, I have a 4, 2 sine x. 2 sine x minus 1 and sine x, let's see, minus 1 plus 4 plus 2. Let's see. So 2 sine squared minus 1 plus 4 is plus 3 minus 2. Yeah, that works. So you get sine x equals 1/2 or sine x equals negative 2. Well, obviously this guy has no solution. So, pi 6. There you go. Why would you do it algebraically? You have a calculator. I only did that because it's kind of fun to do, right?
Just do the intersection.
All right.
Yeah, just do the whole thing.
Okay, moving on. F prime. This is F prime. We want to know where F has a relative max. If we make an F prime sign line, we actually, you don't even need to make an F prime sign line. I can tell you by looking at this, there's no relative max. Okay, without doing any work at all. Why can I do that? How can I do that? Yes, Emma. Okay, so this guy has a degree of a 4, and this guy has a degree of a 2, which means that these guys will never change sign. They're going to always be positive, right? Or 0, right? But they're not going to change signs. Go positive, 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 positive on either side of both of those zeros, right? So the only one we have to look at is this guy at x equals 0. So these are always positive, so this is the only thing that determines the sign, which means we're negative to the left of 0 and positive to the right of 0. We're going negative to positive as a min. Right? So here, let's make a sign line. So we have 0, 2, 3. Negative, positive, positive, positive. Right? So this is our F prime sign line. There's no relevance. Okay, moving on. Average rate of change. So you have, so A rock, F of pi thirds, a lot of trig, over pi thirds minus 0. So I'm going to write it out again. Secant pi thirds minus 0 over pi thirds minus 0. All right. What's the cosine of pi thirds? 1/2. So what's the secant? 2, right? So 2 minus, what's cosine of 0? 1. So what's the secant? 1. So 2 minus 1 over pi thirds. 1 over pi thirds. You get 3 over pi. Something slightly less than 1. All right. Is that okay?
Yeah, no, I did it.
Did you do average value formula?
Yeah.
Oh, okay. If you do this with average value formula, let me just give you a little warning. So when you do the average value formula, so A rock, here's the thing that people mess up on with average value formula. So you have 1 over pi thirds minus 0, integral 0 to pi thirds of whatever you want the average of. We want the average of the rate of change of F, not just F, the rate of change of F. So what goes here? F prime. Right? And then you could throw it in your calculator, but you have to find F prime. So, I mean, it's a lot more work. But anyway. Which, by the way, what's the antiderivative of F prime? It's F, right? So this is just F of pi thirds minus F of 0, which just takes you right back to the original formula. So you're just like going quite roundabout to just do the same thing that we started with, right? But it's fine. It's good practice on average value formula. All right. Well, yeah, why wouldn't you be able to? It's not like it went away, right? Yeah.
I tried to do it, but I didn't do it fine.
Okay, there we go. All right. I'm going to do this again using definite integrals. This time it's much more appropriate because it's a calculator question. You can do this by hand, but I need to warn you. I'm cautioning you because we could easily give you an acceleration function that is non-integrable, right? And then you have to know how to do it using definite integrals. So, all right. So what do? We say, now there's 2 ways to think of this. I'm going to write it first just the definite integral way. So we're going 1 to 2. The definite integral of A of t, what's the antiderivative acceleration? Velocity. So this is v of 2 minus v of 1. Just definition of a definite integral, right? So then this guy, just put this in your calculator, right? V of 2 is what we're trying to find. V of 1 is 1, right? And then whatever you get here, you just add 1. Do you want me to here? I have it. I did this one during first today. Let's see. So I got 1.6386 approximately. Minus 1, so V of 2 is around 2.6386 approximately. Ending velocity equals beginning velocity plus the net change in the velocity. All right. Are people having issues with that? Is mine wrong? You did a L'Hopital?
No.
Oh.
We're just discussing in general.
Oh.
We don't remember it that way. Or at least I don't remember it that way.
Oh, you're asking me to add a L'Hopital into here.
No.
Oh.
Well, maybe if we wanted to, like, if it's already not on the final, don't. Maybe some extra credit.
I don't know how that came up. I'm going to move on to number 8. Okay. Trapezoids. You ready? Trapezoids. Are these widths equal? No. Which means we're going to have to do each trapezoid separately. Although there is one number we can always put in front. 1/2. 1/2 times. What's the width of the first trapezoid? 1. We're going first, second, third, right? So 1 times the sum of the heights. What are the heights?
1 and 2.
1 plus 2. Okay. Width of the next trapezoid. 2 times 2 plus 4. Third trapezoid.
1.
1 times
4 plus 5.
4 plus 1. Alright, and if you put this all on your calculator, I'm pretty sure I remember that this is 10. You will need to know trapezoids and left and right and midpoint rectangles, right? All of those are fair. I'm not saying they're all on there, but they're all fair game, right?
I didn't get the answer for the one before. I just got 5.05. Yeah, I got this.
Because you didn't put your denominator in parentheses. It's doing divided by 5 and then multiplying by x. You gotta put 5x in. Guys, if you have something divided by 5x, that 5x has to be in parentheses if you're on an old-fashioned calculator, right? New calculators, you guys don't have to know your fractions as well. But old calculators, you gotta put that denominator in parentheses. Did you get it? Yep. All right. Let's see. Y equals root x. Y equals 2 is a horizontal line and the y-axis. So that guy right there. We're rotating this region about the line y equals 4. That's 2 odd. What method would you use for this? Washer, right? Horizontal axis, washer. Vertical axis, shell, right? Yes. Okay. So we need a big R and a little r. We always have a pi in front. We're going from 0 to something. This guy right here, this is where root x equals 2, right? Root x equals 2, so x equals 4. So we're going from 0 to 4. Not because of this 4, because of this 4, right? It's just coincidence. If we were going around y equals 5, this would still be a 4. All right, so 0 to 4 of, so big R, go from your axis to the further away function, top minus bottom, so 4 minus root x squared minus, okay, little r, start from your axis, go to your mirror boundary, that's little r, 4 minus 2. It's just set up? Okay, there you go. That varies problem to problem. Yeah. Okay. All right, the position of a particle on a line is given by x of t. Distance traveled. Ooh, what's formula for distance traveled? It's equal to the absolute value of the velocity? The integral of the absolute value of the velocity, right? Okay. And then displacement is just the integral of the velocity. Yes, Kostya? Because distance if your velocity function has positive and negative parts, remember that whenever velocity is positive, we're moving to the right. When velocity is negative, we're moving to the left. So we go right, left, right, right? So if I go to the right and then go to the left and then go to the right, I want the total distance traveled. But if we did this as an integral without the absolute value, it would be subtracting instead of adding this, right? So, all right. So, let's see. So distance equals definite integral first 2 seconds, so 0 to 2 of the absolute value. Ooh, we need the velocity. They didn't even give it. What's the velocity? T. And lucky for you, you have a calculator, so you don't have to know how to convert absolute value to piecewise. I got roughly 6.7698-ish. Questions? Rashmi, you have a question? All right. Mishan, Zuhair, how you two doing? Good. All right. Very chattery today. Yes,
For displacement, would you just be basically like starting or ending point?
you could, absolutely. If it was displacement, you could just plug in the 2 and plug in the 0 into your position function and subtract. Yeah. Or you could, like, do definite integral of the position, or of the velocity without the absolute value and get the same thing. All right, good. So let's put these away. Let me export this. I'm going to pause recording real quick.